All right, so integral exponents, really the idea we're talking about is exponents, and we're talking about integral, specifically exponents. You're like, integral? Does anyone see the word that's inside the word integral? Think of your types of numbers. Alex? Integers. So exponents that are integers is what we're really talking about. Miss Ray, are there other exponents? Yes, there are fractional exponents, decimal exponents. But we're not talking about those today, and probably not for the next couple years. But we will get into that later. Okay, so the first thing I want you to write here is this little expression, 2 to the 4th power. And what does 2 to the 4th power mean? Not what is it equal to, but what does that mean? When I write a big 2 and then a little 4 off to the top, right? What does that mean? Yes, Anna Grace?
2 times 2 4 times.
Okay, 2 times 2 times 2 times 2. That many times?
Yes.
Okay, just like multiplication is a shorthand way of adding, using exponents is a shorthand way of multiplying. Okay, and this is what I wanted to get. Some key words here. This big 2 is called the base of this expression. So of 2 to the 4th power, 2, the big number, is called the base. And I'm going to refer to that a lot, so please remember what the base is. The 4, that little number to the top right, is called an exponent. This is called an exponent. And the whole thing, 2 to the 4th power, this whole thing is called a power. The whole thing is called a power. Or you could say the power of 2. Or 2 to the 4th power. I know that's kind of confusing for some, but when I'm referring to power, I'm talking about the whole expression together. Base, exponent, the whole thing is called the power. Bless you. Okay, and this is what it means. I want you to get this down because when we work out the next type of problems, you're going to be like, wait, what's a base? What's an exponent? Why does he keep saying power? Well, I'm going to refer to these 3 parts a lot. Okay. 2 to the 4th power, or 2 to the 4th, means that the base is being used as a factor how many times? 4 times. So how many times is 2 being used as a factor? 1, 2, 3, 4. Okay, what is 2 times 2 times 2 times 2? What is 2 to the 4th power actually equal? Yes, Hudson? 16. 16 would be its value. Okay. 16 is a number that's written in standard form. You know why we call it standard form? That's how you normally look at a number. 16. What do you think we call 2 to the 4th power? What do we call that form? It's not standard form. We don't normally see numbers with exponents, but we do call it, and it's in your book if you want. It's in yellow, highlighted. Non-standard, in this case, I think I heard it. Exponential form. Exponential form. Exponential form means this. It's an expression that has an exponent. So does this expression have an exponent? Exponential form. So there's a lot here that we're going to be referring to a lot during this lesson. So make sure you get these keys. Okay, I'm going to point to something. You're going to tell me what it is, and hopefully there's no hesitation. Mainly because the answer's on the board. Okay, Mary, what's this number called?
The base.
Henry, what's this number called?
Exponent.
Sophie, what's the whole thing called?
2 to the 4th power.
So what do we call that? We call the whole thing a?
Exponential.
Okay, it's written in exponential form, but the whole thing's called a power. So this is written in a form exponential, but it's called a power. Hagen, what's this written in?
Standard form.
Standard form. Okay. Any questions on that? Pretty straightforward, basic. Yes, ma'am?
Okay. So what 16 makes it standard form? Is that just the answer, or?
Not necessarily, because technically in your homework today, this is the answer. So that doesn't mean it's standard or non-standard, but it depends on what form I ask you to write it in. If I want you to write an exponential form, this is your answer. If I say write it in standard form, That's your answer.
Oh, okay.
So it just depends on what I ask. The middle form right here, 2 times 2 times 2 times 2, we call that expanded form. Do you know why we call it expanded form? Because it was this and now it's expanded. So I hope that makes sense. All right. Let me see if you guys can do it without any words. So please don't look at your notes. Okay. William, what's the base?
3, that's larger.
The bigger size 3, okay? Alex, what's the exponent?
The smaller 3.
The smaller 3. Josiah, what is the power?
3 to the third.
Good, the whole thing is 3 to the third. What form is this written in, Drew? Exponential form. Who can give me standard form? Darius?
27.
Good, 27. What's expanded form on this one? And I'm not going to ask you to write in expanded form, but you could figure it out. Yep, Anna Grace?
3 times 3 times 3.
3 times 3 times 3. Okay. So far, so good. You guys get this? Pretty easy. Because what I'm going to say now is what's the base? Or do this to the base, do that to the exponent. You're like, what's the base of exponent? You need to know those terms. Okay, here's what we're going to do. We're not going to deal with just writing them out in standard and exponential because I think you guys have done that before, but this is what we are going to be able to do. If I have negative 2 to the second power times negative 2 to the third power, what does that equal? What's the value of that? Now, before we get to standard form, I don't want these answers today in standard form. I want them in exponential form. Mr. A, they are already in exponential form. Technically, exponential form means you have it as simplified as you can, and then you have an exponent in there. So do you think it could be made a little bit simpler? How many think maybe this could be simplified a bit? Yeah, just by looking at it, it's like, probably can do something to that. Okay. How many times is negative 2 used as a factor in this first power? Anybody? Twice. So I'm going to write negative 2 times negative 2. So that's right here. Expanded form right here. How many times is negative 2 used as a factor in the second power? Sorry? 3 times. So negative 2 times negative 2 times negative 2. Whew. Imagine if those are bigger numbers. Okay. What's going on between this power and this power? What operation is going on between negative 2 to the second and negative 2 to the third? What operation? Yep, Alex? Multiplication. So can I put a little multiplication sign right there? All right. Who can write this expression in exponential form? As simple as you can. Can anyone do that for me? Jack?
Negative 2 to the fifth power.
Okay, negative 2 to the fifth power. Wait, how'd you get that 5?
5 negative 2s.
Okay, how many negative 2s are used as, how many times is negative 2 used as a factor? 5 times. So that's it. That's it. That is the exponential form. Pretty easy, right? Yes, sir?
How would it not be positive 4 to the 5th?
Say that again. How can it not be?
How would it not be positive 4 to the 5th?
What a great question. How about this? Can you figure out what's negative 2 to the second? What is negative 2 times negative 2? 4? And then what's negative 2 to the third? Negative 2 times negative 2 times negative 2? Negative 8. And what's 4 times negative 8? Negative 32. So that's what the standard form would be, right? So we're just looking at standard form. So what did you say it should be? Negative
4, positive 4 to the 5th.
Positive 4 to the fifth. All right. 4 times 4 times 4 times 4 times 4. 16, 64, 256, 1,000, 256, 1,000. Something big, over 1,000. Negative 32 and over 1,000. Are they the same thing? No. So here's a good good thing we're going to get to, Hudson. Do you notice that the base didn't ever change? All I changed was the exponent. And that's going to be a key to doing these problems. Okay, how many of you understand this process right here? Okay, not too bad. There's an easier process. There's an easier process. What? You guys already know it? Anna Grace, do you know what the easier process is?
Oh, no, I just...
Oh, go ahead.
Okay, so how did you get 4 times negative 8?
Yeah, what's negative 2 times negative 2?
Oh.
Positive 4. And then what's negative 2 times negative 2? That would have been positive 4 times negative 2 is negative 8. Okay, Alex, do you know the easier way?
I don't know, but couldn't you just add the two exponents on top? Like 2 plus 3 plus 5?
Oh, yeah. I guess we could have done that. Wait, does that work? Why do things keep falling? Okay, does that actually work? So you're saying, why don't you just add the 2 and the 3? Wait, what's 2 plus 3? Don't erase it in your notes. But you are correct. If I have two powers that are being multiplied and they have the same base. So look at these two powers, guys. Do they have the same base? Yes. You know what you could do? Add the exponents. That's all you have to do. Add the exponents and you get that. So the way to show the work on this, which is really not that hard, so this is the original problem, is all you have to do is this. You keep the same base and then you add those exponents, which, what's negative 2 to the 2 plus 3? Negative 2 to the 5th. That's your answer. That's all you have to do. You gave the secret away, Alex. Thank you very much. I appreciate that. Okay, let me give you guys a problem, see if you guys can figure it out on your own. Let's go with 5 to the 3rd times 5 to the 4th. Give it to me in exponential form. Bless you. So I don't want standard form because that's going to be a big number. Very big. Okay, can I show you how I did it and then someone else can explain how you did it? Okay, here's how I could do it. Is that correct so far? Yes or no? Okay, good. 1, 2, 3, 4, 5, 6, 7. Yes, 5 to the 7th. Got it. Did you guys get that? Did you do it a different way? What'd you do? Explain it to me. Raise your hand. Okay, Darius?
I just added 3 plus 4.
Why?
Because they're the same base.
Okay. If you're multiplying two powers with the same base, what do you do with those exponents? Add them. Add the exponents. I'm good with that. Now, do you notice I keep saying a couple things? If you're multiplying two powers with the same, and then it got quiet, same base, then I can add those exponents. And there's a reason why I keep emphasizing that. Here is the, we're going to call it law of exponents for, and I'm going to put here multiplication. So here's a way to simplify everything we just said and hopefully make it very clear. So there are two laws. The law of exponents for multiplication is this. A to the m power. What's a and m? They're variables, but they stand for numbers. I don't know what numbers, but they stand for a number. Times a to the n. Okay, these two are powers, correct? They have a base to some power. I don't know what those are, but I know that they have a base and some power. Do they have the same base? Yes. What's the same base? A. What do I do with those exponents? I add them together. M plus n. That's the law of exponents for multiplication. That's it. That's the law. Add those exponents when you're multiplying those two powers with the same base. Whew, that's a mouthful. Okay, any questions on that? Pretty straightforward, I think. Okay, here is the second law. What I want you to do, leave a little gap because we're going to talk about division, and I'll give you that law, but I'll come back to that later. So give a little space there, and I'll give you that second law. All right, here's another problem. 6 to the 5th divided by 6 to the 3rd. So 6 to the 5th. 6 times 6 times 6 times 6 times. Wait, how many 6s? Oh, 5. Oops, take one of those away. 6 times 6. Shh, I'm trying to think. Hold on, I lost that number. Carry the 4. Oh, no, this is too hard. Okay, what I'm going to do is I'm going to show you what process we're thinking through, and then maybe, possibly maybe, there might be a shortcut. Okay, here in this first power, 6 to the 5th, what is the base, Jack? What's the exponent, Matthew?
5.
How many times is 6 used as a factor, William? 5 times. 6 times 6 times 6 times 6 times 6. 1, 2, 3, 4, 5. I'm going to do this. What's that fraction bar also known as? Division. How many times is, in this power, 6 used as a factor? 3 times. So 1, 2, 3. Right? A lot of 6s, a lot of multiplying, and some division. Okay, do you guys remember what any number over itself always gives me? What's any number over itself? 1. Do you guys remember you can cancel things out? Isn't that 1 over 1? Can I cancel anything else? 1 over 1? Okay, what's 1 times 6 times 6 times 6? 6 to the... Oh, sorry, wow, I totally missed this out. Is there anything else to cancel? Yeah, sorry about that. Okay, so cancel out as many as you can. Okay, now, what's 1 times 1 times 1 times 6 times 6? 6 to the... Just give me an exponential form. 6 to the second power. What's 1 times 1 times 1? 1, which we just write it as this. So if I wanted standard form, give it to me, but I want exponential. So you don't put 36 yet.
I was just trying something out and I subtracted the things.
Yeah, I was subtracting 5 and 3.
What? I gotta keep this here. Oh, wait. You're telling me, Drew, and some of you may have thought this through as well, that when you're dividing two powers with the same base, you should subtract those exponents? Okay, keep the same base. 5 minus 3 is equal to 6 to the... No way. Really, that's all you have to do? Second law for division is very similar to the first. For division, a to the m divided by a to the n is equal to a to the m minus n. A to the m minus n. Do you notice in both these types, multiplication or division, we have to have the same base? Like, do you see how they all have to be a to get my a? Both have to be a. And then either I add the exponents or I subtract them. Yeah, that's pretty easy, actually, now that I think of it. Okay, any questions on the laws? Yes, sir?
What do we do for the different bases?
That's tomorrow.
Okay.
That's tomorrow. Is it? Is that it? Okay, I'm going to get to the second part here. That you guys get the laws, we're good. What if you have different bases? We're going to look at that tomorrow. So today, all the same bases, which is nice. Very nice. Be thankful. Or you can say thank you even. That's totally okay. Yeah, I'm okay with that. All right, let's give you another problem, see if we can figure these out. Let's go with 7 to the third divided by 7 to the third. Go ahead and give it to me. Don't say it out loud, please. And this is going to give me a definition that we're going to have to use for the rest of our lives. So not that long. Depends, yeah. Go ahead. Sorry? 1? 1 what? Like, just 1? Like 1 or 1? Oh, just 1. Got it. He says it equals 1. I am very confused by that. Because if I use my law of exponents for division, when I get 7, what's 3 minus 3? I get 7 to the 0, and you're telling me that equals 1. Can someone explain why it equals 1? Because 7 to the 0 does not look like 1. Looks like 7 to the 0. Or maybe 0. Okay, yeah, Gracie, do you know?
So, you know how you did it on...
Yep. Oh, you mean this way, the long way? All right. Oh, not that way. This way? Uh-huh.
And then you would cancel each out, and so it would
Oh, That's true. Okay, I still don't get this right here, but I do know it's true. I know that any number to the 0 power is always equal to 1. So here's your definition. Any number to the 0 power is equal to 1. You need to know this. I'll put a star. I'll put stars out here. Some of you are like, it looks like a solar system or some kind of planetary system. No, it just means it's important. You need to know that. Because I'm going to test you out right now. Write that down. Commit it to your memory. Any number to the 0 power or to the 0 exponent is equal to 1. Like any time. Except for 0, by the way, guys. A cannot be 0. That's the only exception. Because 0 to 0 power is not, I'm not comprehending that. Okay, but I won't give you that. Okay, ready? I'm ready to move on. Yeah, this? Any number to the 0 power is equal to 1. Okay, here we go. What's that? Who's going to knock it out of the ballpark here? That's a curveball. Tiger Woods style. I can't golf, but I like swinging things. Okay, I'm going to give you two options. -1 or 1. So you have two options. So how many of you say -1? Okay, how many of you say +1? How many of you haven't voted? How many of you just hate voting? Like you never vote. Good. You just voted. The answer to this tough question is simply, it's 1. I told you, any number to the 0 power is 1. I don't care if it's -2 or +100. It's 1. How many of you said 1? Okay. Please remember that. Even though it has a negative here, it's still -2 to the 0 power is +1. And if you don't get that, it's okay. I get that. All right. Let me give you a new problem here. So this is a new... See if you guys can get this. 7 to the 4th divided by 7 to the 6th. Go ahead and figure that out for me. And this will get into the third part of our act, which is the last and probably the most difficult part. So we kind of built up something to the 0 power. Man, mister, are you sure that's 1? Pretty sure. Yeah, pretty sure it's 1. But this one is going to be tougher to explain. But I hope you guys can get it. All right. Who has an answer? Michelle, I see that hand. What's your answer?
Not right at all. I said 7 -10.
7 to the negative. Whoa. Michelle and anyone else who got this answer. This lesson is called integral exponents. Integers. So we've been dealing with all these positive numbers, and now we come to this screen, and you're telling me exponents can be negative? No. Or wait. What's an integer? Brad?
What?
What's an integer?
Any number and its opposite.
Any whole number and its opposite. Is -2 a whole number or its opposite? We're dealing with that today. That is correct. 7 to the -2nd. How many of you got 7 to the -2nd? Don't be afraid of those negatives. You take that negative sign and you write it down on that paper and you show it who's boss. All right, tell me what 7 to the -2nd is equal to in standard form. I will give you 30 seconds to discuss with your neighbor. Don't look at the book because then, I know what that is. Just try to figure it out on your own. What's 7 to the -2nd? Don't look at your book. In standard form. So this is exponential form, but I want standard form. What is this equal to, like, as a number without exponents? You are allowed to communicate. You are allowed to talk. Sophie and Mary, you guys can talk, and then you two boys can talk. Let me give you a hint to kind of guide your direction here. 7 to the second would be 49. I'm just giving you a hint. 7 to the second would be 49. So do you think 7 to the negative second would be exactly the same? I don't think so. Can't be exactly the same, but
He said no, so it's no.
it's not exactly the same. Can't be. They're different. You are allowed to communicate. You are allowed to talk. You can talk. Mr. is letting you talk, and so you're like, all right, go ahead. All right, the final answer is not as commonly known, but maybe some of you know. It would be cool if you did. Okay, so 7 to the second is 49. Okay, that I hope you know 7 times 7 is 49. No debate about that. 7 to the negative second is simply 1 over 49. Dun, dun, dun. Did anyone, I just want to ask, did anyone get that? Okay, so maybe some of you, and it's okay. Can I explain something? After I wrote it? Awesome. No, you got it. Okay, let me say this. It's not super intuitive because you're like thinking, wait, how many of you got this answer? Negative 49. And we're getting, okay, common. It's common perception. But let me show you why it can't be negative 49, why it's 1 over 49. Can I do that for you guys? Ready? Gracie, you actually brought this up. 7 to the 4th, 7 times 7 times 7 times 7. 7 to the 6th, 7. All right, make sure I wrote the right number of 7s on the numerator, in the numerator and denominator, because if I didn't, I messed this up. Oops. Okay, we're good? All right, do these 7s cancel? These. This is kind of fun. Okay, cancel. All right, what's 1 times 1 times 1 times 1? 1. 1 times 1 times 1 times 1 times 7 times 7.
Oh my God.
Wait, that's not possible. It's a bomb. Not quite. It's getting there, but not quite. Okay, here's what I'm going to put. It's the second definition that you have to know. So we talked about 2 laws. Law for multiplication, law for division, and then we're talking about our second definition. The first definition, any number to the 0 power is equal to?
1.
Okay, hold on. Swivel felt that. This is connected almost to my heart, it feels like, and Sewell just felt this dropping of the heart when I heard any number to the 0 power is equal to?
0.
Still stings a little bit. Okay, it's 1. It's 1. It's okay. Don't ever do that again, though. Okay. The second definition is this, and I'll write it up here. Any number to a negative exponent, so this time negative n, is equal to, and I'm going to give you a key word that maybe helps you to put this together. Any number to a negative exponent is the reciprocal of its positive exponent. Dun, dun, dun. Can anyone say reciprocal? Reciprocal. Yeah, it is kind of tough. Reciprocal. Okay. So here's another one. Star. Yes, ma'am?
What's the word definition?
The word definition of this? I think I'm going to give it to you. It's on page 25 at the very top, and it gives you both definitions. Page 25 at the very top, it says any non-zero number with a negative exponent. Do you see that?
Yeah.
That's the definition. That's the word form of it. So you can copy that down. And then I'm going to test it out to see if you guys really, really get this down. And that's the last part of this lesson, is to really get that part down. This shirt is not conducive to. You might, if you listen to the video, you might hear it. Okay, here we go. I'm done with this here. I'm going to move on to the next screen. All right, I'm going to test you out. 8 to the second. 8 to the second. second is equal to what in standard form? Standard form. Good. It's just 8 times 8. It's 8 times 8. Oh my. 8 times 8 is 64. Okay. If 8 to the second is 64, what is 8 to the negative second?
1 over 64.
This is 1 over 64. That's correct. Okay, I'm going to give you another couple, and then you guys figure it out for me. So, all right, give me both of those. Don't say it out loud. Just work it out. Figure it out. I mean, you could do it in your head, but some of you might need paper to write that. 36 times 6. But once you get the first one, you can automatically get the second one. Hopefully they're both correct. So don't give it to me out loud. Natalie, you look like you're ready. What's 6 to the third?
196.
So 36 times 6, 196. Wait. 30.
16.
Yeah. That's okay. That's okay. 216. And so what is 6 to the negative third? 1 over 216. It's the reciprocal of what it... So if I gave you this, you're like, wait, I don't know what 6 to the negative third is. Well, what's 6 to the positive third? So the reciprocal would be 1 over 216. All right, let me give you this one. Give me that one first. 5 to the negative third is, don't give it to me out loud, just write it down. I was having doubts on my own. All right, who has 5 to the negative third? Raise your hand if you have it. Don't say it. Okay, on the count of 3, you will say it all together. And if it doesn't come out right, that's okay. We'll notice. 1, 2, 3.
146.
Oh man. I heard many things, but I think I heard 1 over 125. Or 1/125th. All right, I'm going to give someone a pop quiz. Who's the lucky person? I think.
I'm lucky. I was last.
Eva. 5 to the third. Go.
125.
Oh, wow. That was quick. Good. Okay. Do you guys understand that if you know 5 to the negative third, you can instantly go to 5 to the positive third? Okay. When I put a negative exponent, I hope you guys are listening to this. If I put a negative exponent, does it change it to a negative number? No. A negative exponent does not mean it's a negative number. So please don't say this. Yay, I got it, Mr. A. They're all negatives. They are not all negatives. All right, I'm going to give you one last problem, see if you guys realize this is the toughest problem I'll give to you today. This problem right here. Yes, sir?
So this question, if the base is a negative, does that make the number negative?
It depends on the exponent. Actually, I'll give you another problem after this to kind of show that, but let me give you this tough problem.
This is hard to rock.
All right. It's okay. Here's how I'm going to look at it. First of all, that negative exponent really throws me off, and then the fractional part really adds some more to it. Okay, what's the base of this power? 2/3. Okay, if this were a positive 2, how many times do I use 2/3 as a factor? Twice. Can I figure out what that is? It's 2/3 times 2/3. 4 ninths. 4 ninths. 2 times 2 is 4, 3 times 3 is 9. All right, that's what I would get. So that's this answer. Somebody tell me after a little bit of time what that answer is. They're not the same. But if you understand the concept of that word, then you will be able to get that answer, which is, okay. Fill in the blank. My calc teacher in college used to say blah. So if 2 to the thirds to the negative blah is the reciprocal of 2/3 to the blah, what's blah? And then if you're not paying attention, he'd call you, all right, blah? That's correct. I'm like, yes, got it. But my answer is not blah. It is an actual number. Okay, Alex knows it. Does anyone else? Josiah thinks he knows it. Matthew kind of knows it. Michelle. Philip. All right, I'm going to call on someone who didn't raise their hand. So I want Henry to give me the answer.
I don't know.
As in 9/4 is correct. Okay, listen up, guys, because if you want to know how to do this on your own, you should pay attention. How many of you are okay with me 2/3 to the second, and I can even erase this positive. 2/3 to the second would be 4/9.
Yes.
Okay? So 2/3 to the negative second, well, what's the reciprocal of 4/9? 9/4. That's your answer.
Sorry, I'm not ready for this calculator.
That's okay. You won't get this one today, but you will get it tomorrow. So I promise that. Okay. Your homework. All you guys are quiet. Because I can expand that homework very easily. I just change the numbers ever so slightly. Okay, it's going to be that 2 through 11 all. And listen carefully before you start working them out. Can you guys do this real quick so I know I have your attention? Just put your pencil down real quick and just look up at me. Trust me, this is awkward for me when everyone looks at me, but I'm doing this so I can benefit you. So put your pencil down and just look at me. On these problems, I don't want standard form. I don't want to know what 2 to the 4th equals. I just want you to write it as 2 to the 4th. If that's the answer, circle it. So, for example, look at number 1. So now go to page 23 in your workbooks. And then put your pencil down and look at me after you look at number 1. Because I don't want you guys to be lost. Mr. A, I did all the standard forms. I'm like, sorry? Like, well, I don't know what to say because you didn't listen to the instructions. All right, once you get to number 1, look at it real quick, then look up at me. I know you're ready. Yeah, I know, but number 1 is like number 2, so it's helping you out. Okay, 4 to the second times 4 to the third. You can look here now. 4 to the second times 4 to the third. It wants you to write it as an expression with one exponent. So how many exponents do I have right now? 2. That's not my answer. So what do I do here? It's going to be 4 to the
5th.
Yeah, 2 plus 3 is 5th. That's your answer. That's all you have to do. Brad? All right, Brad and William, you guys can do 2 through 20 all. And then I'll talk to you, William, after. Okay, go ahead and get started, everyone. If you have questions, please ask. And this one's only on page 23. Yeah, you can put your books away if you want, but go ahead and work.